relative to a fixed origin O, the point A has got the position vector -2, 7, 4. The point B has got position vector -4, 1, 8. And the point C has got position vector 6, -5, 0. We're told that M is the midpoint of AB. So I first worked out the vector from A to B, and I've done that by doing the B vector take away the A vector. So -4 take away -2 is -2. The 1 take away the 7 is -6. The 8 take away the 4 is 4. I'm then going to half that to work out the A to M vector, because we were told that M was the midpoint. So halving that, we get -1, -3, 2. So I can now work out the position vector of M by doing O to A plus A to M. That's what I've done there. And so this is my position vector of point M. We're then told that point D is on the line A to C. So let me just clear my diagram a bit. Such that AD to DC is 3 to 1. So we've got the line A to C here. And D is on that line. So that A to D is 3 parts and D to C is 1 part. So that's 3/4 of the way along that line. So I've worked out A to C, and I've done that by going A to O plus O to C. So A to O, we've got the opposite direction here. So that's going to be 2, -7, -4. Adding that together with the O to C gives me this A to C vector. And like I just said, A to D is 3/4 of that. So 3/4 of the A to C is the 6 -9 -3. And as you can see here, I've worked out the position vector of point D by going O to A. So again, let me just clear my diagram up. So O to A plus A to D. So O to A is the -2, 7, 4. The A to D, that was the 3/4 of the A to C that we just worked out. So adding those together, we get the position vector of point D, which is 4, -2, 1. So we now know where this new point D is. Let me finish off reading the question. It says, find point N such that OMND is a parallelogram. Now, because there's so much information on my diagram already, and I've already cleared off a load of information as well, there's a lot going on. You can see in red, I've just started to redraw certain bits of the diagram. In particular, the OMND parallelogram. So I've got O, M, already marked those on. I've not marked on N yet, so let me mark N on. N must be up here somewhere if it's a parallelogram. N must be there. I've already marked on the position vector of point M that we worked out in part A of the question, and I've already marked on the position vector of D that I've just worked out a moment ago. And now, using all of that information, I can work out the position vector of point N by doing O to D which is the 4 minus 2, 1, plus d to n, which I know if it's a parallelogram is going to be the same thing as O to m. So we get 1, 2, 7, and that is the position vector of point N. That's the answer to part B.